Good day, everyone. I hope everyone is good. I hope everyone is doing amazing. Hope everyone is doing amazing. I hope everyone is good. My name is Vuyani. I'm a student at NMU. We are streaming live in South Campus. Nelson Mandela University. If it's your first time to tune in to Yebo Tutor, please do subscribe so that you'll be notified every time when we are live and when we are streaming live. Who do I have? Please feel free to chat on the comment section so that we can interact together and speak together and assist each other together. Who do I have? Okay. So today we'll be doing calculus, one of the topics which were introduced in grade 12. Bear in mind that we are preparing for our grade 12 final exams, and we are also now preparing for our grade 12 June exams. So this is my last topic which I'm going to do before we write our control test. So next week we'll practice a control test from the previous years so that we know what to expect when we are going to the exam. Okay. Please do subscribe, please do comment, please do share with friends and family so that we can assist each other in the process and we can be able to understand together. Welcome to Yebo Tutor. Today we'll be doing calculus, and calculus, it carries 35 marks plus or minus 35 marks in your maths paper 1. So now bear in mind that for the past week we were focusing on paper 2. We did analytical geometry, we also did trigonometry, we also did Euclidean geometry. Now we are doing calculus, and calculus, it comprises of 35 marks for your paper 1 June. So bear in mind that calculus is divided into subsections that you must be able to understand. That we have graphs in calculus. You must be able to differentiate. You must also be able to differentiate, and you must be able to solve or to find the first derivative from first principles. Okay. As always, let me start with the overview today. So I want us to understand few things which are so important, are so basic when we're understanding and when we're starting to do. I want us to go and check out. I want us to check at what we call polynomials. Okay. So now, when I define my polynomial, so I will say that a polynomial expression. So a polynomial expression f of x of degree n, where n must be the element of natural numbers, is an expression of this form. So I'm defining it, and I want to illustrate to you what's a polynomial and what is a polynomial expressed. So we are saying that a polynomial is an expression f of x of degree n, where n is the element of natural numbers, and it has this form: f of x is equivalent to a n x to the power n plus a n minus 1 xn minus 1 plus, then plus until we have a2x to the power 2 plus a1x to the power 1 plus a0, and we also know that it's x to the power 0, and x to the power 0 is equal to 1. So it's the same thing with just leaving this as this is, and we go to 0. So this is an expression for polynomial. I'm starting on polynomials because I want us to understand where we are going with calculus. So now what we want us to understand is that on this concept that we just have expressed a polynomial in terms of f of x, provided that the value or the value n is an element of natural number. I want us to understand that the highest power of x is, to remember that we had let me just so the highest power of x, which is this one, must always, it's always the highest power of n is the one which is called the degree of a polynomial. So it's one which will enable us to know that which degree is this polynomial. So we look at the highest power of x. For instance, if we have 7, if we have 5, this specific polynomial, it's a polynomial with the highest degree. So we check the highest degree of x, and so in this case it's 7. So we can say that this polynomial is the 7th degree of polynomial, because it's something which is so important that you understand that it's 4th degree polynomial, 5th degree polynomial, 7th degree polynomial. So all of them, they depend with the highest power of x. Power is the same as exponent. When we were doing exponent, we say that when we are given a to the power x, a is representing the exponent, or it's representing the index, or it's representing the power, and a is the base. So just like that, also we are applying that same knowledge here, that a is our base and x is the power, or x is the exponent. So now we must understand this thing so that we can be able to go further. So this is what I have for you. So now I want us to just have like small example. Let me just say example so that you understand. So for example, maybe we are given f of x is equal to x to the power 4 minus 3x cubed minus 2x squared plus 2x minus 4. So this polynomial, when they ask you to say which polynomial is this, we can see that we say that in order for us to define a polynomial, we must look at the highest power of that specific polynomial. So now, if we look at the highest power of x here, we can see that the highest power is 4. So when they ask us, this is a 4th degree polynomial. This is a 4th degree polynomial. Then we move forward. I want us also to understand that we also have what we call, maybe for instance, we are given g of x is equal to 2x cubed minus 2x squared minus x plus 5. We can see again, we check. Then we can see that the highest power is 3. So this is a 3rd degree polynomial. So why did I start here? Because I want us to understand that here, I want us to understand that in grade 12, we focus mainly on this 3rd degree polynomial, which is also known as the cubic polynomial. Okay, known as the cubic polynomial. So in grade 12, in this year, what we are supposed to know is to understand the cubic polynomial. Bear in mind that we also have different ones. We also have like h of x is equal to maybe x squared minus 4x plus 2. We know that when we're doing quadratic equation, this is also a polynomial, but this one is called a quadratic polynomial. So I want us to be able to understand that. Then, for instance, when we are given g of x is equal to 6, this is called a constant polynomial because it has a constant value. Bear in mind, this 6 is the same as 6x to the power of 0. So we can see that x to the power of 0 is equal to 1. So 6 times 1 is equal to 6. So this is called a constant poly. Then we also have a linear poly. Maybe we're given 2x minus 1. This is called a linear polynomial. So now, what is important, NB, what is important about these polynomials? I want us to be able to understand the cubic polynomial, because we will be dealing with them, and we want us to be able to understand the linear polynomial. Okay, want us to be able to understand the linear polynomial. So now these two are the ones which we are mainly focusing in grade 12. So the cubic polynomial is the one which is the one which is ending, or which has a third degree, which I just illustrated here. See what's going on. Okay, come on. Yes, this one is a third degree polynomial. So that's what we have here. So I want us to be able to understand that concept. So now these two are what is important. So now, since these are important, so now I want us to understand that the first thing which you must understand, we have what we call the remainder. We have what we call the remainder theorem. So I'm just giving you an overview. So on the remainder theorem, what is important for you to understand is that the remainder theorem states that it states that if a polynomial f of x is divided by the linear polynomial. So now we're saying that if a polynomial is divided by a linear polynomial, which one is a linear polynomial? Linear polynomial is a function which is in the form of ax plus b. So this is our linear polynomial. So we're saying that the remainder theorem states that if a polynomial f of x is divided by a linear polynomial ax plus b, this is the linear polynomial, then the remainder. So when they say calculate or determine the remainder of the function, you must be able to determine the remainder by saying f of negative b over a. Where is this coming from? I hear someone asking me that where is this coming from? Check it out. We are saying that we are having ax plus b. So now in order for us to calculate the remainder, we equate this to 0, then we make x the subject of the formula. So x will be equal to, we transpose b to that side, then it will be negative b over a. So now our x value is x is equal to negative b over a, but now we must be able to calculate the y value. So in order for us to calculate the y value, we must substitute in the original value of x. So that's where we place this x now, so that we get the y value, of which in this case the y value is now giving us the remainder theorem. So again, be aware of the remainder theorem. It's so important. It states that if we are given a polynomial f of x, it must be able to be divided by a linear polynomial. And when we say a linear polynomial, we are speaking of this a polynomial which is in the form of ax plus b. So the remainder of that polynomial must be able to give us r is equal to f of negative b over a. Okay. If there's anyone with any question, please don't hesitate to ask. We are here to assist you. Please don't hesitate to ask. All right, let's move forward. Now we have what we call defector theorem. Okay. We have also the defector theorem. So the defector theorem, what is important is to understand that the defector theorem states that if the linear polynomial ax plus b is a factor of a polynomial. So we say that in this grade 12, in this chapter, we are dealing with a cubic polynomial. A cubic polynomial is a polynomial. We say that it's a polynomial in the form of ax cubed plus bx squared plus cx plus d. This is a cubic polynomial. So we are saying that the defector theorem says that if the linear polynomial ax plus b is a factor of this cubic polynomial. So bear in mind, when we're talking about factors, maybe in grade 8, grade 9, we're talking like the factors of 6, the factors of 8. So that's the same thing, but in this case, we are dealing with polynomials. So we're saying that if this linear polynomial is a factor of this cubic polynomial, then we can prove and we can see that f of negative b over a is equal to 0. So that's our factor theorem. And what you must understand that we have the special concept or the remarks which you can conclude on the special factor theorem. We say that the factor theorem is a special case of a remainder theorem where the remainder is 0. So we are saying that the factor theorem, as we have it, it is there because it will assist us to understand that a remainder theorem. That's why I started on remainder theorem. Ne? I started on the remainder theorem so that you can be able to understand and have an overview that a remainder theorem is in this format. So now we are moving forward to the factor theorem. So the factor theorem now, I want us to understand that factor theorem, it is a special case of the remainder theorem where the remainder will be equal to 0. So if you look at this, we say that this, let me just use a different pen so that you can see that clearly. So we say that this is the same as this one, which is here. It's the same one as the one which is here, and said R is equal to this one. So we can see that if we are saying that according to the factor theorem, f of negative b over a is equal to 0, then the remainder is equal to 0. So we are saying that it is a special case of the remainder theorem. Then now, let me move forward now. So now, in analytical geometry, we spoke about something which is important, which is so essential. So now we have what we call now we want us to differential. We have now what we call differential calculus. So what I gave you was just preparing us to this differential calculus. So on the differential calculus, I want us to understand that we have what we call the average gradient. We have the average gradient, which we did on analytical geometry. So now I want us to have this overview on this part, that maybe, for instance, we are given, I plot this graph, then maybe I plot my parabola. If you don't know these graphs, please do check the video. It's available about graphs, which is a parabola. So I say I have my parabola here. I have my parabola. Just use a different pen so that you can be able to see. So we can see that this parabola on this point, it has a x value, x1. It also have an x2. So we know also that on the y-axis we have a value, but this time it's now f of x1. And also, let me not use this part so that you can be able to see clearly. Let me just use somewhere here. Then we have x2. Then when I plot diagonally, we have f of x2. Right, yes. My plotting is so small, but I hope you see that. So we can say that, for instance, this is point A, this is point B, and we can see that point B, it is x2 and f of x, f of x2, and A is just x1 and f of x1. Right. So now, when they say calculate the average gradient, we know that the average gradient of the line AB is y2 minus y1 divided by x2 divided by x2. That's the concept we know. But now I want us to understand that the gradient between line AB, let me just write it, average gradient will be equal to, so we say that y2 minus, let me start with the one which we know, y2 minus y1 over x2 minus x1. That's the average gradient we already know. So now we also, now I'm gonna introduce this one, average gradient. Again, the average gradient is equal to, so now on the position of y, to check on my plotting here, I shifted some few things so that you can be able to see. Check it out. So on the point B, we said B is a point which is x2 and f of x2. So bear in mind that f of x2 is representing y2. So also on the same A, we said that A is a coordinate which is x1 comma f of x1. So now the part of y1 and y2 is now replaced by the function which is f of x1. So now we are saying that on this part we now gonna write and substitute with the value of, f of x2 minus f of x1 divided by x2 minus x1. Then I can also have the last one, the average gradient. Then my average gradient now, check it out. This, I can let this, the difference between here to be called h. So when we say x2 minus x1, I must get h. So I'm just letting that two variables to be x2 minus x1 to be equivalent to h. So bear in mind that if that's the case, so we can just write the average gradient now will be equal to f of x plus h minus f of x divided by h. That's now where h is equal to x2 minus x1. So now I want us to understand something which is so important, that if that's the case now, That's something which you must be able to understand. So I'm giving you 3 formulas to calculate the average gradient. Why am I doing so? Because I want us to go to the first principles of calculus, because first principles is where there is so essentiality and is the core of differentiating in calculus. Okay, so now we have known these equations. I'm going to come back to them because they are linking to each other. Then now we have what we call a limit. So a limit, we know that a car has a limit. We know that you also have a bank limit. Everyone has a limit. You know, everything has a limit. So now we have what we call limits in maths, in calculus. So the limits of a function f of x as x tends to a is L. So when we say that the limit of f of x as x tends to a is equal to L. So that's a limit. So now as I'm reading it, that's how you can also read it. That's how you are supposed to read it, so that you can be able to apply it logically. So I'm saying that the limit of f of x as x tends to a is equal to a. What does this limit mean? What does this statement mean? It means that the value of f of x, gets closer and closer to L. So the value of f of x gets closer and closer to L. It gets closer and closer to L as x gets closer to a. So that's what we are saying, that now, as I say, that the limit of f of x as x tends to a is equal to L. What does this mean? It means that the value of f of x gets closer and closer to L, provided that x gets closer and closer to the value a. And now, in order for us to calculate the limit, now we must only just substitute x is equal to a in f of x. Then we can be able to determine our limit. Now, also now I want us to have an NB on limits. So what is important on limits is to understand that the limit of a constant remain a constant. I feel like I must just do 2 examples here. Let's just say example. Determine the limit of the function 2x as x tends to 3. So how do you determine this? We say that in order for us to substitute to calculate, we must substitute the value of x is equal to 3. X is equal to 3 in the function of f of x. So we're just gonna have 2 times 3 and we have 6. Then I also say that NB, that the limit of a constant, it's always a constant. So if we're given the limit of x as it tends to 3 of maybe 6, it's still 6. It doesn't change because 6 is a constant. So those are my limits. Why am I doing this? Because I am preparing you to this concept now, which is important and so essential. So we have this concept which is called differentiation. Spelling differentiation from first principles. Differentiation from the first principle. So I want us to understand that earlier on we said that the average gradient between line A, B can be calculated using the formula f x plus h minus f of x divided by h. That can give us our gradient. So that's where I want us to go now. So I want us to highlight that fact that we highlighted that the average gradient of line AB is equal to f of x plus h minus f of x divided by h, where your h is equal to x2 minus x1. So now what does this mean? It means that as h decreases, the average gradient of the line between A and B gets closer and closer to the gradient of the tangent at point x. So what does this mean? So it means that the gradient of the tangent. So the gradient of the tangent is, so now that's when we are now introducing f prime. F prime is representing f prime of x, the first derivative. First, this one is representing first, or it's called f prime representing first derivative, okay, is equal to the limit of h as it tends to 0 of f of x plus h minus f of x divided by h. So this is now what we call we are differentiating according to the first principles. So now this f prime of x is called the derivative from first, from first principles. Okay, so I started by giving average gradient because I know that it's building to where we are really going. Sorry. So now, what does this mean? This means that the gradient, just use a different color because this is essential for us to remember. That means that the gradient of the tangent is equal to the derivative at point of contact. So the gradient of a tangent, is equal to the point of contact. This x is representing x is equal to the point of contact, because we know that a tangent, it's a line that only touches one point on a circle. So our tangent only touches one point on a circle. So that's so important that you must be able to understand that a tangent only touches one point at a circle. So when they ask you to determine or to derive, or they ask you to determine f prime of x from first principles, what are you supposed to do? You are supposed to use this formula. We say that f prime of x is equal to the limit of h as it tends to 0 of f of x plus h minus f of x divided by h. Then after that, you can be able to solve. 5-mark question. 5-mark question. Now, we have what we call general differentiation, because this one, it's long, the first principle. So we have what we call general differentiation. So the general differentiation now, I just I want us to just focus on this one thing, that we have what we call the power rule. Okay, so on the power rule, if we are given that f of x is equal to axn, then f prime of x will be equal to f prime. We said f prime is the derivative of f of x, is the first derivative of f of x. So what will be our f prime? Our f prime will be just n times a xn minus 1. So what is that's the power rule. It's easy. That's the general differentiation. You don't have to go using the first principle, because you just have to write ax to the power n. If you are given ax to the power n, you just multiply the coefficient of x times the index of x. Okay. Then after that, you subtract 1 on the index or on the exponent of x. Then after that, you can be able to get your differentiation. Let me just make a quick example. If f of x is equal to 2x to the power 3, then f prime of x, we say that we must say 2 times 3, x3 minus 1, then we get 6x squared. So that will be our first derivative of x. That was a small example which I wanted to show you. So now, first derivative, or the general differentiation, we can illustrate the general differentiation in 3 essential points. So if they give you, okay, so if they give you f of x, you must have an answer which is in the form of f prime of x. If they give you y is equal to something, your answer must be dy over dx, representing that you are differentiating y in terms of x. For instance, example, if you are given y is equal to x squared, your answer must be dy over dx. When you are differentiation, therefore dy over dx will be equal to 2x to the power 1. What does this mean, dy over dx? It means that you are differentiating y with respect to x. We're differentiating y with respect to x. So that's our general differentiation. And also when you are given a dx of maybe x squared minus 1, so when you differentiate, that's when you only leave this dx. Then after that, you can now just differentiate and say it's 2x, then you leave the dx. So those are the three forms which you must be able to remember when you are writing. And also we must understand, and you must be able to know that NB, I love my NBs, we must be able to know that the derivative of a constant is 0. E.g., let me make a quick example. E.g., if we have g of x is equal to 6, this is the same as 6x to the power of 0. So 0 times 6 is 0. Then 0 minus 1 is negative 1. So we can see that anything times 0 is equivalent to 0. So don't worry yourself. The derivative or the derivative actually of a constant is equivalent to 0. Then you must be able to determine the equation of the tangent. This is my overview, guys. I'm almost done with the overview. Then we'll look at few questions. So for instance, you are given this graph. Mine is ugly. For instance, you are given this graph. Yeah. So now we say that a tangent, and we know that a tangent is a line that touches the graph 1. So this point is called the point of contact. So I can just say that this point is A, f of A, because it's a point of contact. Then I also have this point, and this is the function of f of x. So when they say that determine the equation of the tangent, when they say determine the equation of the tangent, how do you do that? It's easy, because we said that earlier that the gradient of the tangent is equal to the first derivative of x, where this x is the contact point of the tangent. So in this case, our contact point is x is equal to a. So in other words, we are saying that the gradient of the tangent is equal to f prime of a. Okay, so that's how you determine the gradient. We know that in order for us to calculate the equation, we use the equation y minus y1 is equal to m, where m is the gradient of the tangent, minus x1, and x1 and y1 is the contact point. So that's how you determine your equation of your tangent. Okay, then now moving forward, when now we are talking about the turning point. So in order for you to determine the turning point, because bear in mind that we say that we are dealing with a cubic polynomial which is in this form or in this form. Those are our two graphs. It can either be an increasing function or a decreasing function. So what is important is to understand that at turning point, you must write this English when you're answering a question, that at turning point f prime of x must be equal to 0, so that you can get the values of x. Bear in mind that when you do this, it shows that you know your concept. Then when you get the x value of the turning point, as always, we substitute the x value of the turning point into the original equation which you're given, so that you can get the value of y, and you have a coordinate of x and y. Right, then let's move forward a little bit. We also have something which is important that you must understand. So we say that my graph can be like this, and it also can be like this. So when they ask you for which values of x will the function of f of x increase, we know that according to analytical geometry, when we were doing straight lines, we know that in a straight line only, or a function actually only increase provided that its gradient is positive. For instance, when we are given y is equal to 2x minus 3 and they say plot this graph, we can see that when we are plotting this graph, our y will be equal to negative 3, then our x must be equal to 3 over 2. So when you are plotting this graph, where is 3 over 2? Somewhere here. So we have 3 over 2, then negative 3 is somewhere here. We can see that this line, it's an increasing function. Everyone can see that it's an increasing function. So we are saying that when they ask you for which values of x, it's usually a 3-mark question. So when they ask you for which values of x is this specific graph increasing, we know that an increasing function is only when the gradient is positive. So you don't have to worry. So you just have to say that f is increasing on which interval does x increase, f increase. It only increase when, or provided that f prime of x is greater than 0. F prime of x is the same as the gradient of the line. And we say that the only way a function or a straight line increases, it's only when it has a positive gradient. So when you are saying a positive gradient, it is when the gradient is greater than 0. So in other words, our cubic function, it can only be an increasing function, or it can only increase provided that f prime of x is greater than 0. Bear in mind that f prime of x is illustrating or is showing the gradient of the specific function which you are given. And as the same note, it also f decreases how when the gradient is negative. So the gradient is negative, which means it must be less than 0. So what does that mean? Which means that our f prime of x must be less than 0. Then if you are doing pure maths, proceeding now, we have what we call the second derivative. So the second derivative is now f prime of x. So in other words, you differentiate the first time and you differentiate the second time. So this is essential for students, because now you must understand that now we can now be able to determine the minimum point and the maximum point of the function. So in order, if they ask you to determine the minimum point of the function, you just have to determine f prime of a, provided that you are just given a point a is to f prime of a, then maybe we are having this function and this is that point. So we are saying that f prime of a must be greater than 0 so that it can have a minimum point. Okay, a minimum point. Then if f prime of a is less than 0, then it will have a maximum point. So these are so essential. Then also what is important about this thing is that we have what we call the point of inflection. We have what we call the point of inflection. So what is important about the point of inflection is that how do you calculate the point of inflection? Or when they ask you to calculate or determine the point of inflection, sorry for my spelling, inflection. How did you determine the point of inflection? You are just only asked. So you write this English. Say that when they say determine the point of inflection, what do you respond? You write that at point of inflection. Write that English so that you get few marks. At point of inflection, f prime of x is equal to 0. So in other words, you solve for the second derivative of x, then equate it to 0. Then the last thing which I want to highlight is that you must be able to plot these cubic polynomials. You must be able to plot these graphs. How do you plot these graphs? It's so important that you understand that this function is in the form of f of x is equal to ax cubed plus bx squared plus bx plus cx plus d. So this is our polynomial. This is our cubic function. So we must be able to plot this function though. So the steps to be able to plot a cubic function is that we must first determine the x and the y intercept. So we know that how do you determine the x-intercept? We let the y equal to 0. And how do you determine y-intercept? We let x to be equal to 0. Then after that, you must be able to determine, must also determine the value of the turning point. So the turning point, we say that we first calculate the first derivative of x, then we write the English, say that at turning point, at TP, f prime of x is equal to 0, then we get the values of x. Then those values of x which we got, we will substitute them in the original equation which we have been given. Then also know that we say that our graph can be either like this, or it can either be a decreasing function. So these are the turning points. So you first be able to determine the x and the y intercept, then also determine your turning point so that you know where your graph is turning. So sometimes now it can happen that you may be given already a function which has already been plotted for you like this. Then they ask you to determine the equation of the line. So there is this equation, f of x is equal to a x minus x1, x minus x2, x minus x3. We can see that this function has 3x intercept because it's a cubic function. So we use what we call the x-intercept formula, which we also applied last time when we were dealing, or when we were talking about functions as well. So that was my overview. So I highlighted everything. I started from polynomials, then from polynomials I went step by step until we arrived here. What is important in this section is to be able also to understand the application of calculus. So in other words, we apply calculus when maybe they give us a shape, or maybe they give us a scenario that maybe a ball is projected upwards and it reached the maximum height. So they will ask you like, what is the maximum, which it has reached. So you must be able to use the concept of maximizing using the concept of calculus. So that's the application of calculus. So that's my calculus, guys, for you. That's my overview. So if there is anyone with any question, please do ask on the comment section. I am ready to assist you. Please do ask if you have any question, any form of a question. Please do ask. If you have any question, please do ask. Before we go and do questions, we are about to go and do questions. So before we go and do questions and apply what we did, questions, please talk to me. Please talk to me. Please talk to me. Is there anyone with any question or who needs more clarity on something? Is there anyone who needs clarity on something? Sorry. Is there anyone who needs clarity on something? Before we do any question, is there anyone who needs clarity on something? Is there anyone who needs clarity on something? All right. All right. So we have a question already on the board, ready for us to do it. All right, let me maximize my screen then, if there's no one with any question. All right. Now, maximize. Right. Now, question number 7. It's always question number 7. In your paper 1, be it's June or it's December, they're always asking the same formats. They're always asking the same question. Determine f prime of x from first principles if f of x is 3x squared minus 5. Now, let's read. Determine f prime of x. Determine the first derivative of x from first principles if f of x is equal to that function. So they've already told that we must determine the first derivative, but we are not supposed to use the general differentiation, because we know that if we use the general differentiation, our answer must be 6x. But they highlighted the fact that you must be able to use from first principles. So now we must use first principles. So what does the equation of first principles tell us? Or if you still remember the first principles equation, so it's 7.1. It said that the f prime of x, nope, it says f prime of x is equal to the limit of the function f plus h minus f of x as it is divided by h. So we are given that f of x is equal to 3x squared minus 5. That's the function which you are given. But we don't know f of x plus h. So we must first calculate f of x plus h. So we have f of x plus h, then which is equal to 3x plus h squared minus 5. Then now we can use our tricks. We can use how good we are. We can use our we can use our algebraic skills and factorize and solve. All right, so we know that this will be x squared because you first square the term, then you multiply this, is xh, then you put a 2 in front, plus you h squared minus 5. Then this is the same as 3x squared plus 6xh plus 3h squared minus 5. So that's my f of x plus h. So now I can be able to calculate the first derivative because now I know this, I also know this. So now come on, help me, let's do this thing together. So f prime of x will be equal to the limit as h tend to 0 of, what is f of x plus h? We calculated it, it's 3x squared plus 6xh plus 5 plus 3h squared minus 5 minus, what is our f of x? It was 3x squared minus 5. Then we all divide everything by h. Now let us remove the bracket. So I started by not removing the bracket because if we remove the bracket, and we might forget that this negative sign here is subtracting everything. This negative sign here, it's subtracting everything. This negative sign is subtracting everything of this f of the function of f of x. So if we forget that, we'll be in trouble. Then we'll get a wrong answer. So please make sure that you don't do that. Okay. So now we proceed. You don't leave your limit because you have not yet solved your limit. So you proceed with the limit always until you get your final answer. So we have 3x squared plus 6xh plus 3h squared minus 5 minus 3x squared plus 5 divided by h. Then 3x squared minus 3x squared, it's 0. Then negative 5 plus 5, it's 0. Then what are we left with? We are left with the limit as h approaches to 0 of 6xh plus 3h squared divided by h. Now, the next step is we proceed with our limit. Then we can see that there is a common factor on the numerator, and the common factor is h. So we take that numerator out, the common factor in the numerator, which is h. Then now we are left with 6x plus 3h, all divided by h. Then we divide h and h now. Then now we are left with the limit as h approaches 0 of 6x plus 3h. So we say that when we were solving a limit, we say that in order for you to solve the limit, you just substitute h is equal to 0 in the function of f of x. So in this case, you will be substituting the value of h is equal to 0 in this function of f of x. Then you have 6x plus 3 times 0, which is equal to 6x. So that's our f prime of, therefore f prime of x is equal to 6x. So that's our answer. So this is a question which everyone must get marks because it's direct forward. What you do first, the moment they say first principles, your mind must give you this formula. They must give you this equation because that's the most important question, the most important equation ever. You must know that equation by head. You must know it by head. You must know and be able to apply it because it's important. It's really, really important. So that's how. But also on your formula sheet, which you'll be given in finals and trial, it's also there. So that you can understand it. So what you do when they say first principles, make sure that you write the formula first. Then you write, this is my given. I was given that f of x is equal to 3x squared minus 5. But on the equation of determining, according to the first principles, I don't know f of x plus h. So I start by determining f of x plus h. Then how do you do that? You can see that initially it was f of x, but when now we are speaking with the language of function, we say that when a graph is like this, now it's f of x plus h, which means it has been shifted horizontally 3 units to the left. Okay, it has been shifted 3 units to the left, but in this case it has been shifted h units to the left. So we just apply that, the same notation, the same knowledge we apply in the original equation. Then we can be able to get our f of x plus h. Then now our equation is fully satisfied. So what do we do after our equation is fully satisfied? We substitute in the original equation, in the equation of finding the first principles. Then after that we get our answer, which is 6x, Now let's proceed. Right, 7.2.1. Now we are going to general differentiation. Determine dy over dx if y is equal to 2x5 plus 4x3, 4 over x3, sorry, 4 over x3. So how do you solve this equation? So before, we must make sure that everything is on top. So we go y is equal to 2x to the power 5 plus 4x to the power negative 3. Okay, but now everything is sorted. Now it's in the notation that we can apply our power rule. So what do we do after we see that? Now we can now derive dy over dx. You don't apply dy over dx when you have not yet set your question, when you have not set the y value in the correct order so that you can apply the power rule. You only use dy over dx, or in other words, you are using dy over dx as an indication that now I am deriving. Okay, so when we are deriving now, so now we know that according to power rule, it's 5 times 2 is 10. Then we say 5 minus 1 is 4. Then 4 times negative 3 is negative 12. Then we know that negative 3 minus negative 1 is negative 4. So that's our dy over dx. We are done with that one. Now let's move to the second one. That one was straightforward. That one was a bit easy. Then we are given 7.2.2. That one is a bit tricky. Y is equal to, open bracket, square root of x minus x squared. Okay, all squared. So now we are given a tricky question, a little bit tricky. We're given a question which is a little bit tricky. So we must also be tricky at that part. Okay. So we know that what I would advise, first thing which you can do in this instant, make sure that you open your brackets. So you have square root of x minus x squared. Then you also have square root of x minus x squared because it's being squared. Then after that you simplify. Then root x equal to root x times root x, it's x. Root x times negative, it's negative root x of times x squared. Then this times this is also negative root x times x squared. Then negative x squared times negative x squared, it's let me just fix that, sorry, squared, yes, it's positive x to the power 4. Then now we have x minus this and this, they are like terms, so we have negative 2x squared times root of x plus x to the power 4. Then this is in set form, so we know that we can write it as x minus 2 x squared times x, this is 1 over 2 plus x4. Then these bases are the same, so we can add the numerator, so we can say that is now x minus 2x to the power of 2 plus 1 over 2, that's 5 over 2 plus x. Sorry about that. Then now we have the y value. So after we now have the y value, now we can apply dy over dx is equal to 1, 5 over 2 times 2, negative 2, then x, then 5 over 2 minus 1, that's 3 over 2, then 4 times 1 is plus 4, then minus 1 is positive 3. So this is now our differentiation. So how did we tackle this question? We started by opening the brackets. We started by expanding the bracket so that we can expand and have one expression. Then when we are here, we saw that these two, they are having the same base, and we know that according to the rules of exponents, that when you're having a to the power x times a to the n is the same as a to the x plus n. So this 5 over 2 is coming from adding the exponents of 2 plus 1 over 2 so that we can get, and we were able to get 5 over 2. Then after that we differentiate. Okay, then after that we were able to differentiate in our question. Oh, we are done. So you already have your 12 marks in the bag. Wow, you already have your 12 marks in the bag. You already have your 12 marks in the bag. Is there anyone with any question before we proceed? Is there anyone with any question before we proceed? Okay, awesome. Let's move now. We are doing our almost last question. Let's move. We are doing this. This is our last question. Oh, it also have this one. I want us to do that one as well, the maximizing one. Then let's try to be fast. Let's try to be fast. Please, if you have any question, do ask your question. I am here for you. I am here to assist you. I am here to help you. Don't hesitate to ask. Type on the, or you can even type on the WhatsApp group. We have the WhatsApp group, and the link is also in the description of this video. You can also ask your question so that we can assist you. Okay. Question number 8. Question number 8. Sketched below are the graphs of f of x is equal to x minus 2 squared, open bracket, x minus k, and g of x is equal to mx plus 12. Oh, we are given two functions. And we can see g of x is a straight line. It has intersection of point A and B. So when you are reading the statement, you must be able to read and you analyze the statement so that you can be able to see, oh, wow, this is what they need. Okay. So now they also told that, sorry, A and D are the x-intercept of f. A and D. So A is this point, and D, they are the x-intercept of the function. So we already know that A is a point which is y is to 0. Okay. We already know that. Please just give me 2 minutes, please. Just want to fix something. Okay, thank you so much for waiting for me. There was just this thing, minor thing I have to fix. Okay, cool. Now, question 8. So I was saying that when you are reading your statement, always analyze and apply what you know. So now they told that A and D are the x-intercept of f. So we already know that A, let's just write that down so that you can see it as well. So as I'm reading my question, I'm analyzing it as well. So I already know that my A, since they said it's an x-intercept, so I already know that, I don't love this color. So I already know that my A, it's an x-intercept, and x-intercept, which means it has an x and a 0 value, and also my D, it's also x and also 0. Then it continuously reads as follows. Now, as it continuously reads, it says that B is the common y-intercept of f of g. So we know now that B is a y-intercept, which means that x is 0, and we just have to know the y value. And it's common for both functions. So we're also told that C and D are the turning points. So we know that TP, it's C and D. Okay. So then the straight line passes through A and B. We can see that function G is a straight line. Then now our question was, first question, write the coordinates of B. What are the coordinates of B? B, we say that B is a function which has 0 and y. And we are given initially we are given the, let me just write that as well. We are given the function of f of x to be equal to x minus 2 all squared, then x minus k. Then I also given graph of g of x is equal to mx plus 12. All right. So now they say the first question, which is for 1 mark, write down the coordinate of B. Where is B? B, we say that B is a y-intercept, and B is also located on G. So now, coming to our given information, which we have written down on our own, we saw that B is 0 is to 1, and B is found on F and G. So we can use one of these equations to find our value of y. So how do we do that? I want to load the value of G of x. So we just substitute there. Let me just say 8.1. So we have y is equal to mx plus 12. So I want to use this one. So I want to substitute B, which is 0 is to y, because they told us B is a y-intercept. So now we know 0 is equal to m times 0 plus 12. Then we can see that y is equal to 12. Then therefore the coordinates of B, it's 0 is to 12. Just like that, boom, you have your answer. Just like that, you have your 1 mark in the bag. Every mark counts in the exam. Please don't forget that. Then now calculate the x coordinate of A. The x coordinate of A, here is our A. How can we calculate the x coordinate of A? How can we calculate the x coordinate of A? How can we calculate the x coordinate of A? What do we know about point A? We know that point A and point D, they are the x-intercept of the function of f of x. So how about we start calculating the value of k by substituting b in f of x? Okay, so what do we do now? So we know that we are given, just do this. Okay, so we know that we are given f of x is equal to x minus 2 all squared plus, let me just use y. We know that, okay, f of x is equal to y is equal to, yes, then we can write it in this manner. So now let's substitute our value of b, which is 0, is to 12, so that we can calculate the value of k. Because bear in mind that we already know that b is also on the function of f of x. So we are gonna have 12 because this is y. We substitute 12, then have 0 minus 2 all squared, then have 0 minus k, then it's 12, then negative 2 squared, we know that it's 4, then negative k, it's negative k. So now we can divide both sides by negative 4, then we end up having k is equal to positive negative 3. And we can see that really it's negative 3. So therefore we can finally see that therefore now our k now it's x plus 2 all squared, x minus 2 all squared, then x plus 3 all squared is equal to 0. So when we are solving for x, we can finally see that x minus 2 all squared is equal to 0, or x plus 3 is equal to 0. So therefore x can either be plus or minus, yes, it can be either plus or minus, x is actually positive 2, or x will be equal to negative 3. And we can see that a is on the negative x-axis, so therefore we can see that the coordinates of a is negative 3 is to 0, because it's on the negative side. We can see that a is on the negative coordinate system. Okay, let's move forward. Is there anyone with any question? Please do ask if you have one. Then let's move forward. Now if k is equal to negative 3, wow, calculate the values of c. What is c? Where is c? C is the turning point. So now they have already told us the value of c. Okay, so now we know that 8.3, we already, according to what they told us k is equal to negative 3, right? So now we can say that f of x is equal to x minus 2 all squared, then x minus 3, which was the value of k which they give us. Then we just substitute plus 3. Then after that, let's solve this equation. We know that this is x squared minus 4x plus 4, then we multiply by x plus 3, then we expand x cubed. We have x cubed plus 3x squared minus 4x squared minus 12x x cubed plus 3x squared minus 4x minus 4x squared, then minus 12x plus 4x plus 12. So we expand in that formula, then we can finally say that our f of x is equal to x cubed minus x squared minus 8x plus 12. Okay, so after that, this is now our function of f of x. So we know that c is a turning point. They told us c is the point which is a turning point. So we know, what do we know about the turning point? We know that at turning point f prime of x is equal to 0. So now let's determine f prime of x. So f prime of x, which is the first derivative of x, will be now is 3x squared minus 2x minus 8. Then after that, please, I advise, write this English that at turning point, so that we know what you're writing. So at turning point, f prime of x must be equal to 0. Then after that, we are saying that 3x squared minus 2x minus s must be equal to 0. Then we find factors. We use the quadratic formula straight. Don't try to find factors if it's hard. Use the quadratic formula so that you can get one answer final, just like that. So if you're gonna use factors, we can see that you're gonna have 3x. Gonna also have x, we have 2, we have 4. Yes, equal to 0. So those are our factors. Then we can see that 3x plus 4 is equal to 0, or x minus 2 is equal to 0. Then therefore our x is negative 4 over 3, or our x is equal to positive 2. Where is our x? Where is our c? We can see c is on the negative side. So which means therefore our c is negative 4 over 3 is to y. So now let's calculate the value of y. How do you do that? We substitute c negative 4 over 3 comma y into where are we substituting? We're substituting in f of x. So now we can substitute in the value of f of x so that we can get the value of y. So when we are substituting the value of f of x, then it will be y is equal to negative 4 over 3 all cubed minus negative 4 over 3 all squared minus 8 negative 4 over 3 then plus 12. Okay, we are substituting the value of negative over 3 in the equation of f of x, which is here, which we were able to determine on our own. So when we substitute the value of x there so that we get the y value, please use your calculators. Use your calculators, then we can find that the answer will be 500 over 27. I use my calculator. Don't try to use your head. You break your head. Use your calculator, which is approximately the same as 18,52. So therefore we can see the coordinates of c is negative 4 over 3 is to 500 over 27. So that's the coordinates of c. So what is important here, we realize that c is a turning point. Then after that, we were told that the value of k now is negative 3, so that we just expanded the equation to a standard form of f of x of a cubic polynomial. Then after that, we were able to anticipate to know, since we say that c and d, they are both turning point. And what do we know about a turning point? We know that a turning point at a turning point is equal to 0 at turning point. A turning point f prime of x, a turning point f prime of x is always equal to 0. So we use that knowledge. Then after that, we're able to calculate the value of c. Then after that, we're able to analyze that c is on the negative x-axis. So we cannot say c is equivalent to 2, because bear in mind that we got two values. We got x is equal to negative 4 over 3 or x is equal to 2. So we were supposed to see which side, which one is this one. We're supposed to see that which one is this one. Then we were able to see that c is on the negative side. So since it is on the negative side, now we can definitely say that the value of x is equal to negative 4 over 3. Then we substitute the value of x into the original equation. Then we're able to get our value, which is 500 over 27. Are you guys still with me? I'm excited. I'm doing the last question of the day now. Due to time, I'm now doing the last question of the day. For which values of f will f concave down? We talk about concavity. So we say that in order for us to determine whether this function will concave up or up, we determine the f prime of x. So the second derivative of x is what is important, so that we can be able to determine. So what is the second derivative of prime? So we say that the f prime of x is equal to, we determined it right now, guys. We say that is 3x squared minus 8x plus 12. So now we must determine f prime of x so that we can determine whether the graph concave. They say that the x value on which this graph will concave down. So we know that it's 6x minus 8. We are differentiating there. Then we know that write this simple English. It will give you marks, because you show that you understand what you're saying. Okay, so that we know, so that at concave down, we know that f prime of x must be equal to 0. Or you cannot just write this, you can just equate f prime of x to be 0. Then you have 6x minus 8 is equal to 0. Then your x now will be equal to 8 divided by 6, which is the same as 2, which is the same as, is it 8? Because my f prime, let me check, just double check from what we solved earlier. Oh, it's negative 2. I just swapped here, I'm sorry. Negative 2x and minus 8. Oh, so here it's supposed to be negative 2. Please forgive me for that. I just did a silly mistake. So 2 over 6 is the same as 1 over 3. So it's x is equal to 1 over 3. So what I always urge is that you must be able to know that f will always concave down when concave down, provided that f prime prime of x is less than 0. What was our f prime prime of x? It's 1 over 3. So therefore we must say that x must be less than 1 over 3. So that's our concave down, guys. So that's what I had for you. But it won't be fair if we don't do the maximizing or the application of calculus. Let's apply the application on question 9. Let's apply the application. So when we are applying the application now, we must read the question. Okay, a 340 milliliter a 340 milliliter can with height h centimeters and radius of r is shown below. All right, determine the height of the can in terms of r. Determine the height of the can in terms of r. We were given a 340 milliliters, which means we are already given that that's the volume. So we know that that's a cylinder. So what is the volume of a cylinder? So we are now applying the knowledge which we know. The volume of a cylinder is equal to, okay, let's do this. Yeah, the volume of a cylinder is equal to pi r squared times h. So we are given the volume to be 340 milliliters, and we know that is pi and it's r squared h. So now they say determine the height. So in other words, make height the subject of the formula. So we must divide both sides by pi r squared. Then therefore we can see that our h is equal to 340 divided by pi r squared. So that's my h. You see, easy. You get your 3 marks for just showing that. We are doing the application now. Okay, calculate the length of the radius of the cane if the surface area to be calculated is minimum. Wow. So now they're already telling us the surface area is minimum. So what do we know about this cane? We know that this is a cylinder. So how do you calculate the surface area? We know that the surface area is always equal to 2 pi r squared plus 2 pi r h. Okay, so what do we know about h? We know that we calculated h right now, and it was 2 pi r, and our h was 340 over pi r squared. Then now we end up having 2 pi r squared plus, then we divide this pi and pi, we divide this r and r, then I'm left with 1 r there. Then we end up having 680 divided by r. Okay, then after that we know that we can write this in a function form. So we are having 2 pi r squared plus 680 divided by 2. This is the surface area of a cylinder or of a can. So now we said at minimum, so which means that you must determine a prime. Okay, so when you determine it, we can see that 2 pi is a constant. 2 times 2 is 4 pi r. Then this was over r. So now when it's over r, we must be able to determine, where is this? It was plus r, yes. So we must be able to, when we raise it up, it will be 680 r negative 1. So it should be negative here in the middle. So it's negative 680 r negative 2, which is the same as 4 pi r minus 680 over r squared. So that they said at minimum, so we can definitely say that at minimum, which means it's 0. So the surface area must be equivalent to 0. Then now we have 4 pi r minus 680 over r squared is equal to 0. Then after that, you are now solving for r. So you can solve for r in your own way. You can solve your r in your own way. So I was going to say 4 pi r is equal to 680 divided by r cubed. Then I have divided by r squared, sorry. Then I have r cubed is equal to 680 divided by 4 pi, because you cross multiply and divide at the same time. So r squared and r is r cubed. Then we divide both sides by. So we can now determine the cube root. so that we are left with r, which is equal to 3.78 centimeters. So that's our r. So just to redo this, oh my word, I'm sorry, I forgot to remove this. So on the second question, they said determine calculate the length of the radius in centimeters if the surface area is minimum. So what do we know about the surface area of a cylinder? We know that the surface area of a cylinder is equivalent to 2 pi r squared, 2 pi r squared, it's equivalent to 2 pi r squared plus 2 pi rh. But initially in the first question, they told us to calculate the value of h. What was our value of h? Our h was equal to 340 divided by pi r squared. Then after that, we calculate, and we saw that when you substitute, there are like terms there, then they cross, then you say 2 times 340, then we get 680 divided by 2. Then now we can finally say that AR. So we can also write area in terms of a function A, the function of A in terms of R, because you can see that the function A is going hand in hand in R. And bear in mind, A is my surface area, guys. So after that, I was able to see that then we know that at minimum, because that the minimum, where the surface area is minimum, we know that at minimum, the first derivative of an area must be equivalent to 0. So I started by calculating my first derivative, and we know that 4 pi is a constant, so it's 2 times 2 pi is 4 pi r. Then we use the general differentiation, then we were able to get our final answer. Then after that, we equated it to 0, then we calculate, then we get our r to be 3.78. Then that is what I had for you guys today. So today we did calculus. It was so an amazing session. Please do share with friends. Please do share. Please do comment. Please do join our WhatsApp group. Please also don't forget to subscribe so that whenever we are live, you can be notified. Also, we also have our Facebook page. I think next week or that week we'll be streaming live on also Facebook, so that you can also see us on Facebook. So till we meet again, have a blessed night, and I wish you all the best with everything.